right, here we have another calculator free response problem. And this time they're giving us two functions and they gave us a graph, and I went ahead and put the graph on my calculator. So this is what you're seeing is the same thing that's underneath it there. And the first thing they want you to do is find the sum of the regions R and S. And R is the first region and S is the second region. So the trick is that top minus bottom change because these curves intersect each other. So the first thing we'll have to do is find the intersection of the curves. So we go to F5, and choice 5 is intersect. And we say, sure, that's the first curve, sure, that's the second curve. And then lower bound, we have to actually click over to the left side of the intersection, enter, and then upper bound, go to the right side of the intersection, hit enter. And actually, in this problem, you're going to get a point just for writing down that intersection point. So let me write that down because we're going to need it several times throughout this problem. So 1.032, I'm going to write it up here. 1.0328 was the first point, or was the x value. Then the y value is 2.401. So 2.401. So then what we have to do is set up an integral where we have top minus bottom, and x starts at 0 and goes all the way to 2, and we have this crossover happening at 1.0328. So top curve is g of x for the first integral. So I'm just going to write in here g of x minus f of x. And you can either write in g of x minus f of x, or you can actually write the actual equations in. It does not matter. And you are integrating on the limits from 0 to 1.0328. And then you're going to add to it the integral from 1.0328 to 2 of now f of x minus g of x dx. So that's your setup, and then we're going to go to our calculator where we're going to get the actual answer. So to get the answer, we're going to go to the home screen. I've already typed in the two functions f and g. So I'm going to integrate the g function, which was the x to the fourth function, minus the f function. And I'm going to have to open a parentheses to make sure that entire function is put in paren, because we need to subtract out the entire function. Comma x, comma 0, comma 1.003, excuse me, 0328. So that gives us the first area. That's the area of R when it finishes. Okay, now the area of S we have to integrate again, and this time we're going to integrate the top minus bottom is going to be the F curve minus the G curve, and don't forget to put the whole G curve in parentheses, so you subtract out, distribute that negative, comma x, comma 1.0328, comma 2 for the upper limit of integration. So the area of S is going to be 1.006. So to get the whole area of R and S, I need to take the area of R plus the area of S, and that, when I hit enter, gets me 2.004. So let me write that down here, equals 2.004. All right, for part B, you are taking just the region S, and you've got cross sections perpendicular to the x-axis that are squares. So you have effectively f minus g that you are squaring to get these cross sections as squares. So your setup is going to be your f function minus your g function, all squared, dx, and then the limits of integration are going to be 1.0328 to 2. So we could go back to our calculator, and I already had f minus g in this integral here. So I'm going to pull it in, and I have my limits of integration correct. What I need to do is I need to square my f minus g. So I'm closing a paren and putting a square there, and then I have to go all the way back to the beginning of the f function and put an opening parenthesis right there. Let's hit enter. I think I did it right. Let's just make sure here. calculator's going to think for a second. Oops, I didn't mean to hit escape. Now I've got to go again. And once that calculator finishes thinking, we find that the answer is 1.283. And then part C of this question says, if h is the vertical distance between the graphs of f and g in region S, so right here, f minus g, then find the rate at which h changes with respect to x at x equals 8. So you have h equals f minus g, which means h prime equals f prime minus g prime. So then what we're trying to do is evaluate h prime of 1.8. So I'm going to do this in my calculator. I'll have to differentiate each of f and g and evaluate them at 1.8. And I meant to write 1.8 right there. So let's go back to the calculator again. And we're going to go up first to the f function, which was the 1 plus x function, which is right here. And I just hit enter to bring it back down in, but what I really want to do is differentiate it. So differentiate, grab it, comma x, close parentheses, and then we're going to evaluate this derivative at 1.8. So you do scroll to the right and then hit a such that x equals 1.8, enter. Let's do the same for g of x. So differentiate, and then we're going to go all the way up and grab the g of x function, which is right coming up there. Comma x to differentiate with respect to x. Scroll to the end and hit such that x equals 1.8. So now h prime is f prime minus g prime. And in my calculator, I find out that that is negative 3.811 or 812. So negative 3.811 or negative 3.812. Either one works. So again, for all these problems, you just have to put in your setup and your answer.